Hello and welcome. You were just introduced to polynomial division, that's lesson U1A4, and we looked at both long and synthetic divisions. And problem number 6 was one of the assigned homework questions. Now let's take a look at it together. So let f of x equals x to the power of n minus 1. It seems that we are dealing with a polynomial function where n is an integer bigger than or equal to 1. So the question is f of x always divisible by x minus 1? And justify your decision or explain your decision. So before we move on to the solution, a few things about problem-solving techniques. So whenever you are solving a problem, just read the problem in general to get an idea what it is about. And then read it a second time and try to look into every single term and make sure you understand the meaning of it, okay? So in this case, for example, I would suggest that we look into the information given, for example, that n has to be bigger than or equal to 1. Try to envision all those numbers. So what that means is that this function can have the power of n equal to 1, or power of n equal to 2, power of n equals 3, power of n equals 4, and so on. Now, next, is f of x always divisible by x minus 1? So make sure we understand the meaning of the mathy words that you see here. For example, the word divisible. So when do we say a number is divisible by another? Best to explain this through an example, I would say. So for example, if we divide number 6 by 2, then the answer is 3. We say that number 6 is divisible by number 2 because there is no remainder. Remainder is 0. Another way of saying this is that x minus 1, or number 2, divides evenly into 6, which means it divides without leaving any remainder. So in the context of our problem, if we divide x to the power of n minus 1 by x minus 1, then we should have no remainder. It is very important we understand the terminology so we understand the question we're asked. So let's get started with our actual question. So if f of x equals x to the power of n minus 1 is divisible by x minus 1, it means that if we were to divide x to the n minus 1 by x minus 1, then we will be left with a remainder of 0. So in order to prove this, then we're going to try to divide this actual polynomial expression by x minus 1. And for this, what I'm going to do is I'm going to rewrite the polynomial expression x to the n minus 1 slightly differently. So I'm going to start off with the term x to the power of n, which is the term given. And as you know, whenever we perform division, especially synthetic division, we want to make sure that all the powers are shown in the division. So if you are starting with the highest power of n, the next term must be the term that carries the power 1 less than n. So x to the power of n minus 1. And then the next power will be n minus 2, so 1 power less, n minus 3, and so on and so forth until we hit x to the power of 1. And then last but not least, x to the power of 0. So this is the format in which we want to write the polynomial expression, and I'm going to add the operation of addition in between for now. Obviously, this is not the expression we're given, but what we are going to do is we're going to use this frame, right, in order to rewrite our expression. So x to the power of n is the first term in our polynomial, so we're going to leave it there. Now, we don't have other terms that carry x to the power n minus 1. So what we're going to do in this case is we're going to leave this one as a placeholder, and we're going to give it a coefficient of 0. And then the same thing with x to the power of n minus 2. So again, we're going to give this a coefficient of 0. A coefficient of 0 because these are placeholders that actually are not part of the expression. We're just using them to indicate that here are all our terms from highest to lowest degree. And in the similar way, we'll continue with the rest of the terms. We don't have to write them all. We see the pattern, so we're going to have just coefficient 0. And as you can see here, we have x to the power of 1. Again, we don't have an x term, or x power 1, so we're going to give this a coefficient 0. And x to the power of 0, as a matter of fact, is the constant term because x to the power 0 is 1. So instead of writing x to the power 0, I'm simply going to write the number 1. And as you can see, you have number 1 in here, but we have it with a negative sign, so we're going to switch it up to negative. So if you look at all the coefficients we have in this beautiful expression, it seems that we have the coefficient of 1 for x to the power of n, and then 0, 0, 0, 0, and our last coefficient is negative 1. So what we are going to do is use these coefficients, so 1, 0, 0, 0, we can continue on 0 and then negative 1, and divide this by the polynomial x minus 1. So when dividing by x minus 1 in here, it means that the value of b would be equal to positive 1, which means that the number 1 will sit right here. And we're talking about this number 1 right here. And we're going to perform the synthetic division as we normally do. Bring number 1 down. So multiply the number 1 that we brought down, the pink number 1, by the value of b, which is also 1. And 1 times 1 would be equal to 1. We add, and 0 plus 1 will be 1. So same idea. We will multiply now this number 1 in here by 1. So we follow the exact same process as we normally do in synthetic division. And that will give a number 1. We add 0 plus 1, 1. Same idea again. We're going to take the pink one, multiply it by the green one, and that will give positive 1. We add, that's a 1. Now, as you can see in here, we keep repeating, or we keep obtaining the same number, number 1. So you can imagine that no matter how many terms you choose in between, we're still going to get the number 1. So what we're going to do is we're going to jump this with this number 1 and go right here at the next term. Sorry, I'm going to have to make this one pink. And we're multiplying this 1 by the number 1. And we're going to say that this one that was somewhere obtained from these terms will give us the product of 1 here. You add 0 plus 1 would be 1 again, all right? And as you can see, we have arrived to the last term in here. So again, we're doing the same thing religiously. So we have number 1 multiplied by the green one, and that would equal 1. You add, and as you can see here, when you add 1 and negative 1 together, we get the number 0. So that means that our remainder equals a smiley face. I'm kidding. So the remainder would equal 0. So we are going to say that the expression x to the power of n minus 1, which we wrote it in this fancier way, right, so that we could perform the synthetic division here, will divide evenly by x minus 1 because we will obtain a remainder of 0. Thank you for watching, and I hope that this made sense. Bye for now.